All right, so we'll skip like number 1 and number 2 because those seem to be already pre-set up for us. We'll look at numbers 3 and 7, okay? So again, this is all review. So I'm not expecting people to be like, whoa, I've never seen this before, because we literally just saw it a month or less ago, okay? So it hasn't been that long since we've done this, but they just wanted you to remember how to do this. Now, I know that the instructions on this homework says solve each equation with the quadratic formula. You don't have to, okay? You can do it by factoring if you find that easier to do. But if you find like, oh, I can't factor it, I'm going to have to use a quadratic formula, then feel free, all right? So the first one, we're going to try factoring if we can. If we can't, then we'll do the quadratic formula. So let's see. Remember, in order to solve quadratic functions, you need to set them equal to 0. So that what I'm going to do right now is I'm going to add 3 to both sides. Okay? So adding 3 to both sides gives me the following. 3x squared minus 3x plus 5 equals to 0. Okay? Now what I'm going to do is I'm going to try to factor this time. I know it says use a quadratic formula. I prefer factoring. It's easier. The quadratic formula is less thinking, but usually the answers look really odd because you have square roots and stuff all over the place, right? So let's try to keep it easy. Let's see if we can factor this one. So I'm going to make a little x over here, and I'm going to multiply 3 times 5. That's going to give me 15. Remember, this is my a, my b, and my c, right? So my a times c, that's 15. On the bottom goes a negative 3. And I got to think of two numbers that multiply to 15 that give me a negative 3 when I add them. So what two numbers multiply to 15 that give me a 3 when I add them?
5 and 10.
Well, 5 and 10 will add, but 5 and...
Oh, no, 5 and...
Let me write this out. 5 and 3, a lot of people will say. But if I add them, I get what?
2.
I get 8, right? If I subtract them, I get 2. So it's not going to work, right? This isn't going to work. Even some people have said, well, maybe it's because one of them has to be negative. But yeah, but then if one of those two numbers is negative, when I multiply them, it comes out to a negative 15, not a positive, right? So we got a little problem. We can't factor, right? We cannot use this. So then we are forced to use the quadratic formula. Okay? So let's go back to remembering hopefully what the quadratic formula is. So it's x equals to negative b plus or minus the square root of b squared minus 4ac divided by 2a. I'm going to get rid of all this stuff that I wrote over here. That way it's just not a big mess. So I have my formula there. All I have to do is plug in my numbers and simplify. Okay, so let's go ahead and do that. So x is equal to negative b. b is negative 3. So negative of a negative 3 is a positive 3. Okay. Square root of b squared. Well, since b is negative 3 and I have to square it, I get 9. Minus 4 times a times c. So 4 times 3 times 5. Okay. And then divide that by 2 times a. A is 3, so 2 times 3 will be 6. Now let's just continue to keep working through this thing. So 3 plus or minus the square root of 9 minus 3 times 5 is 15 times 4 is 60. So this would be 60 here over 6. 9 minus 60 is negative 51, right? So let's write that down. X is equal to 3 plus or minus the square root of negative 51 over 6. Now, in the first section that we did, 4.0a, we learned about complex numbers, and we said anytime you see a negative inside of the square root, erase it and write the letter I next to it, right? So here we go. X is equal to 3 plus or minus the square root of 51i over 6. And that's your answer. Because the square root of 51 cannot be broken down into a nice a nice set of numbers with square roots. The 51 can be broken down into two numbers. That's 3 and 17. But 3 and 17 do not have nice square roots. So we're done. Okay? So this is kind of the reason why they said, hey, do these problems. Oh, by the way, use the quadratic formula. Because you can't do them any other way. They're imaginary solutions. Okay? So you wouldn't find actual answers by factoring. You're going to have to find the imaginary solutions. So that's number 3. Now let's look at number 7. So number 7, 5m squared plus 3m plus 1 equals to 2m squared. Remember, you guys have done this before. The only thing that's new is that now we're getting the letter I coming out, right? So we're getting the letter I showing up. So I'm going to move the 2m squared over. And that gives me 3m squared plus 3m plus 1 equals to 0. Now you can try to factor it using normal factoring methods, but it's not going to work. Okay? Don't write this down, okay, what I'm about to do, but check it out. If you did the x method, 3 times 1 is 3. The b value is 3. What two numbers multiply to 3 that add up to 3? None. Right? It's not going to work. So that's why they're like, okay, figure out your A, your B, and your C, and use your quadratic formula. So let's go ahead and do that. Again, I will rewrite the formula. It's always good to do the rewriting of the formula when you don't know it, because it's a way that you can force yourself to memorize it without actually trying to memorize it. If you rewrite it 3 or 4 times, you'll have it memorized. Okay? And you're not even going to try to do it. It's just going to happen. Okay? So x equals to negative b plus or minus square root of b squared minus 4ac over 2a. Get your a, b, and c's and plug them in. So let's see. X is equal to negative b. B is 3, so it's going to be negative 3 plus or minus the square root of b squared, that's 3 squared, that's 9, times 4 times a times c. So 4 times 3 times 1. Okay? And divide that by 2 times a, which is 6. 2 times 3. Okay, now simplify the inside. So we get x equal to negative 3 plus or minus the square root of 9 minus 12 over 6. Well, 9 minus 12 is negative 3. So x is equal to negative 3 plus or minus the square root of negative 3 over 6. There's no way I can simplify a radical 3 anymore. Okay, there's nothing I can do to it. But that negative inside, I can move it out and put an I instead, right? So the letter I. So I'm going to do that to finish off the problem. Negative 3 plus or minus square root of 3I over 6. And that's my final answer here. So again, everything we've done up to this point, we've done before. The only last little step that we did that we've never done before is bringing out the negative from the square root. That's the only thing that's new. Okay? So if you were good at doing these problems before, you're still going to be good at doing those problems. It's just now you're going to say, okay, I got a negative 13 in the square root. What should I do? Get the negative, take it out, write the letter I instead, and you're done. Okay, so this hopefully looks familiar and you're not going to struggle with it. I hope. You're just using a formula and working with it. Okay, but now turn this over. So again, 1 through 8. Oh, by the way, number 8, when it says, could you solve these equations by any other method? So normally for number 8, you'd say yes. But since all the square roots are going to be negative, then there's only really one way to do it. With quadratic formulas. Okay? So when they ask you, could you solve these equations by any other method? You put no. If you tried solving by graphing, would any of these equations cross the x-axis? We actually talked about this before. When a problem doesn't cross the x-axis, one of these parabolas, let's say it just looks like this, if it doesn't cross the x-axis, that means there's no real solutions, but there are imaginary solutions. So for the second part in question 8, if you tried solving by graphing, would any of these cross the x-axis? The answer is no. So for number 8, your answer should be no and no. There is no other way to solve these. You got to use quadratic formula. And no, they would not cross the x-axis. Okay? So that's how you know you have imaginary solutions, is if a parabola doesn't cross the x-axis. All right, so I told you guys that I wanted you to get rid of 11 and 12. I want you to try 10, but we're going to do number 9, okay? Now, I know this is going to seem a little overwhelming. Look at the instructions. It says border problems. You must use quadratic equations. Please challenge yourself. Okay? Because we know they're tough. But I'm going to show you one, and if you basically do what I do for number 10, you'll be able to solve it. It's just going to maybe have different numbers, but you'll be able to solve it. Okay? So, number 9 says, the Smiths have decided to put a paved walkway of uniform width around their swimming pool. So first, let me draw what's supposed to be their swimming pool. Okay? So this is their swimming pool. All right, there it is. Now, they said that they want to put a paved walkway of uniform width. That means that all the way around, the width is going to be the same. So here we go. That means that this width here is x, and this right here is x, and this is x, and this is x. Because we don't know the width of it, okay? But they said it's uniform, so I'm just going to say that it's a letter X, and every side has that same width. So are we okay so far? So we drew a picture of the pool, a picture of the pavement that they're going to put around the pool, and they said that it's going to be the same as wide all the way around. Okay, so X on every single side. So far, that's what the first sentence has told me. Okay, they decided to put a paved walkway of uniform width, so everything's X. Notice number 10, they also use the word uniform width. Okay, so there you go, X is all around. All right, around their swimming pool. They say the pool is rectangular pool, and it measures 12 feet by 20 feet. So we'll put 20 feet this way and 12 feet this way. So 20 by 12. Now they say the area of the walkway will be 68 square feet. So the walkway itself, so this, I'm going to shade it in purple here. So this walkway, if you were to take the area of it, it's going to measure 68 square feet. So the area is 68 square feet. They say find the width of the walkway. In other words, find X. What's X equal to? All right, so I know this kind of looks like, oh my gosh, how the heck am I supposed to do this? Well, area of a rectangle is length times width, right? We know that. Now, what I could do, if I want to find the area of just the walkway, let me try to do this in a picture form. Wouldn't it be good for me to find the whole big area and then subtract the swimming pool? You guys understand that? Take the whole area, like in other words, pretend that they put concrete over the whole thing, even over the swimming pool. Find the area of that and then just subtract the area of the swimming pool. Wouldn't that just leave me with a shape that looked like this? A shape like that with a hole in it? You guys see that? Okay, so we're gonna get the whole area, including the pool. We're gonna find the area of everything, and then take out the area of the pool, kind of like cutting it out from a piece of paper, right? So think of it like this. If I can, hold on, give me a second here. So just getting this piece of paper here. So let's pretend this is the walkway including the pool. And what I want to do is I want to take away the pool. So what I'm going to do is I'm just going to cut out the pool. So I'm going to do this. By subtracting it. In math, subtraction is the same like using scissors on paper. And then all I have left is that. That makes sense? That's going to be the walkway. Okay? So I have to take away the swimming pool. Right? I got to take away the swimming pool. So this is how I'm going to do this. What is this whole length right here? Well, the whole length across is going to be x plus 20 plus x, going this way. So x plus 20 plus x, or 2x plus 20. That's the whole length. Okay? That's 2x plus 20. Now I'm going to draw that picture that I did right now. I'm going to draw it again, okay? Just give me a second though. What is this distance here? Well, that's x on top, and then 12 for the pool, and then x again. So that's 2x plus 12. Now I'm going to try to draw the little squares that I did earlier, but this time I'll label them. So we're going to have a big space, and we're going to subtract a pool. Okay, we're going to subtract the pool, and our answer is going to be this big shape without the pool. Okay? So let's label what we know. What are the dimensions of the swimming pool? Like, what is the length of the swimming pool? This way. 20. So I'm going to put 20 right here. What is the width of the swimming pool? 12. Okay, great. What is the length of the whole space? 2x plus 20. What is the width of the whole space? All right. So, you guys have done area before, okay? Algebra 1, geometry, you've done area over and over again. So, all I'm going to do, okay? All I'm going to do is get the area formula for the first shape and subtract the area formula for the second shape right now, okay? So remember, area formula is length times width, right? Area is equal to length times width. So, for the big shape, the area is length, which is 2x plus 20, times width, 2x plus 12. I mean, that's the formula for that shape. 2x plus 20 times 2x plus 12. Minus. And then the area for the pool is 20 times 12. How much is all of this area supposed to be? Look at the problem. What is the total amount of area they said? 68. So we just did the hard part, the building of the problem. Now we just got to kind of put everything together. Okay? But before I move on, does anybody have any questions as to what I did? They tell you in the problem, draw pictures, draw diagrams, because pictures help. Okay? I drew these pictures because I think it might help you to understand, like, oh, we're taking this area and we're going to subtract this area, and that's going to give me the shape they want. Right? I actually use this same technique in calculus when we do, in calculus AB in chapter 7, we do areas of three-dimensional figures. So we like get a piece of paper, let's say something like this, and we spin it around real fast, And when we spin it, it creates a cylinder, like a disc, as you spin it over and over and over again. You guys have seen those little noise makers that people spin and it makes really annoying sound, right? But it spins fast, and as it's spinning real quick and you look at it, doesn't it look like a three-dimensional object? Right? It looks like a solid object, but it's not. Well, the way I teach it to them is through pictures. I tell them, look, let's draw this two-dimensional object, and as we do this, we're going to cut this piece out, and then the same thing I do with them. Okay, because it helps them see it. So let's go ahead and do the work here. All right. So we're going to distribute or FOIL the first one. So this is going to be 4x squared plus 24x plus 40x plus 240 minus 240 equals 68. Now notice I can cancel out those 240s. Right? 240 minus 240. Those are going to go away. So I have 4x squared plus 64x equals 68. But I'm not supposed to solve right now. It's supposed to be equal to 0. So let me subtract 68 on both sides. Okay, so minus 68. So we can bring it over here. So 4x squared plus 64x minus 68 equals 0. So they said to solve these, use the quadratic equation. Okay? Before you do that though, because these numbers are pretty big, you can actually divide all of those numbers by what? By 4. All those can be divided by 4. So let's divide everything by 4. I get x squared plus, what is that? 16x minus 17 equals 0. And now I'm going to use my quadratic formula. Okay? I know this seems like a whole bunch of work, and I agree, it is a lot of work. Okay? But if you follow what I did here and do number 10, it's going to kind of be the same idea, just obviously the numbers change a little bit. But you're going to get a big piece minus a little piece and set it equal to the area that they tell you. Okay? So let's go ahead and use this. This is my A, my B, and my C. So x equals negative b plus or minus square root of b squared minus 4ac over 2a. By the way, you could actually factor that one. Okay? But we're just going to pretend we didn't know. So b is 16. So negative 16 plus or minus b squared. Now b squared, 16 squared, that's 256 minus 4 times a times c. So 4 times 1 times negative 17 over 2 times a. That's 2 times 1, so 2. So let's see. X is equal to negative 16 plus or minus 256 plus 4 times 17. What is that? That's 28, so 68 over 2, and 68 plus 256. What do we get with that? I'm just doing work on the side here. That's 4, 2, 324. Okay, so 324. Someone do me a favor, because I don't know. Is the square root of 324 18? Can someone check that for me, please? Let me write this down here.
Yeah.
Okay, good. If not, I was going to start sweating just a little bit because it needs to be a 2. So, all right. So we got square root of 324. We said that's 18. So x is equal to negative 16 plus or minus 18 over 2. We have 2 solutions, okay? But you got to figure out which one works. So x is equal to negative 16 plus 18 over 2, or x is equal to negative 16 minus 18 over 2. Well, negative 16 plus 18 is 2, and 2 divided by 2, That's 1. Negative 16 minus 18 is negative 34. Divided by 2, that's negative 17. Which one of these does not make sense when we talk distance? Yeah, this one makes no sense whatsoever because distance can't be negative. So what is the width of the pavement? It's 1 what? 1 foot. All that for that. I know, that's crazy. But you know, the crazy thing is that construction workers, and funny enough, 2 years ago, we had a whole bunch of work done on our house. And they had to redo the driveway because we were still using the old-fashioned asphalt driveway. And it was all breaking apart. You guys ever seen the black driveways that have like the little rocks on them? And if you fall on them, they hurt really bad because you get like little rocks stuck in your knees, right? That used to be the cool thing to have back then, but now they want cement. So we had the work done, plus they did our house and everything. But it was kind of interesting because the guy's like, let me try to figure out how much cement I need for you. And he literally did one of these. And I was looking at him like, you're actually using quadratic equations? He's like, yeah, you have to. And I'm like, I wish my kids were here, like my students were here to watch you do this right now. So they can see like that even just construction work, you need some basic math. Sure, you may not have to do yeah, this actually is considered basic math. I don't mean basic like 2 plus 2, but these are like the foundational mathematics stuff, you know. So anyway, there's your answer to 9.